Hi guys, good evening. Can you hear me?
Yes, sir. Good evening.
Thank you. So let us start session. I hope everyone, yes, able to hear my voice and screen also visible, right? My voice is audible and screen also visible. Fine.
Yes.
Let us start session. Just a minute. Yeah. So let us start session. Yes, last two classes. So Monday, Tuesday classes. Last two sessions. 24th March. Day 1. About course introduction explained here. So nothing discussed. Yeah, I hope everyone, yes, old students, no one is there new today. Yeah, so this is day 1 about myself, about your course, about course contents, prerequisites. Next, what next after this course? This is a day 1. All introduction classes explained day 1. Next, course syllabus and all that. Very clearly explained. Okay. Yes, course content. Yes,
Sir,
still
actually, this is my first class. Okay, so I'm joining today only.
your first class, huh?
Yeah.
Yes, nothing discussed, just only introduction, just only, yes, information about the course given, course information. Course information, just first of all, about myself, Finetist. Yeah, 20 plus years of experience in the Java full stack developer. Lot of experience. Okay. Yes, development as well as training, both experience. I have very good experience. Yes. I was in US for 4 years. That's all briefly about me. Next, about your course, Core Java. Duration 75 days, 75 days. Time 7:15 to 8:40. So 90 minutes class. Monday to Saturday classes. 3 demo classes free of cost. You can attend 3 classes. Okay, right? So here daily recordings plus class code. Yes, code. So means code. The coding. Class Java coding. What are the Java coding we are writing that code? Daily class document, entry questions, coding skills related document, test papers, all are sharing to your Gmail ID. It's 24/7 that WhatsApp communication is available. Fees only 4,000. 24/7 support is anytime you can ping me. So they about course information. Okay, 75 days, daily 90 minutes class. Monday to Saturday classes, only Sunday holiday, only Sunday holiday. Right? Yes. So about course content, so all the topics here. There's 75 days of topics. So initially first month focus on coding skills. Main focus on coding skills. First 1 month. Next Java oops. Next Java oops. After that strings, exceptionally collections, input output streams, networking and others, right? Yes, finally Java 8 features. Java 8 features in total 300 plus programs I'll explain, including Java 8 features. Okay, still if you want to see that clearly, course details and then syllabus. Yes, search for Durgasoft new batches. Durgasoft new batches. Here you can see. Yes, open that new batches. Click here. New batches. See this. New batches. Your core Java. See, core Java with Java 8 features. by Mr. Nageswar Rao. Right? See, course content. Here you can see. Course with Java 8 features. Yes, course content. Click here. Open, see this. Course information, batch, date and time here. Duration and all that. Yes, course Java, that is complete syllabus. Complete syllabus. Complete syllabus. You can go through here also. More information about course, this is. Yes, go to Durga website here. Check for course content. Course content. Click on this. You can see all that content. Syllabus you can see. That's okay, fine. Okay. Durgasoft new batch. Search for it and check it. Okay, fine. So this is first day. Right? Next second day, yesterday. Day 2. Yesterday, just Java overview explained. Like what is Java? Java history. Why Java has this much of property, present position of Java. Okay. Feature of Java. Just overview. Nothing discussed. Is not a Java class. Simply Java overview explained. Not actual subject. Just only overview explained. Overview. Yes. So this day 1, day 2, I'll share you just to go through that. It's not a big thing here. Overview explained here is not actual classes. Just overview explained. Of course, this will be repeated. So once Java started Java, yes, once Java classes started, this topic will be repeating. That this will be repeating. Don't worry about this. The day 2, don't worry. That again getting. Day 2 topics getting again. No worry about day 2. Even day 1 also no worry. Just only all about course info. Day 1 course information. No worry. Day 2 Java overview. That will be repeating once again. Now, today topic. Yes, today starting actual classes. Okay. Now here starting from the basics. Yes, I'm entering the subject here. Starting from the basics. So before going to Java, there are some software basics. Before going to Java, there are some software basics. So before going to Java, there are some software basics. So let us see all these software basics first of all. Okay, software basics. So once you, yes, clear about software basics, then easy to understand Java. So I'm starting with basics here, software basics. See, this is our class document. Our class document. Yeah, today topic from the servers. So page 1. So this is today starting. So today all these software basics here. Once basics completed, then you can understand Java. Yes. So basics like yes, starting with basics. Basics like OS. What is OS? What is OS? Next, what is interpreter? Yes, interpreter and compiler, interpreter and compiler, interpreter, compiler. Next, yes, languages, different languages. Okay, different languages. So different languages. Okay, interpreter, compiler languages. Okay, next, yes, about front end. So front end softwares and back end softwares like this. There are different kind of things. We'll discuss about, let us say about all that basics. So once basics completed, then easy to understand Java. Okay, so before going to Java, there are some basics. Let us see all that basics here. Yes, I'm starting from very scratch. Starting from very scratch, even non-IT background. Non-IT background students also can understand it. Non-IT, yes, like mechanical background, civil background, electrical, electronics, maybe pharma background, maybe commerce background. Any student can understand my classes. My class is like a spoon feeding. Very clearly I'll explain. Okay, I'm starting from basics here. See, first of all, yes, computerware. So computerware basically two categories. First one, hardware. First one, hardware. Second one, software. Hardware and software. So what is hardware? Hardware, so these are physical components of a computer. Hardware is a physical components, physical components of a computer, physical components like keyboards, hardware, like keyboard, mouse, monitor, next RAM memory, hard disk, all the physical components. We can touch that parts, right? Okay, it's a hardware, but not necessary for us. Not necessary. We are the software engineers, right? We are software. So let us start this software here. Yes, we are software engineers. So I'm starting software. So what is software exactly? What is a software? See, in software, everything is a program. Everything is a program. Everything is a program. In software, everything is a program. Yes, it is a collection of programs. It's a collection. It's a collection of programs. Software is a collection of programs. Programs such as C program or C++ or inside of OS, some programs, OS programs like that here. All are programs here. Java program, Python program, like this, there are many programs. Software, everything is a program. Yes, it's a collection of programs such as C, C++, OS programs. Right? Yes, here software basically two categories. Software basically two categories. Software basically two categories. First one, system software. First one, system software. Second one, yes, application software. Second one, application software. Second one, application software. System software and application software. Software basically two categories. First one, system software. Next one, application software. Yes, anyone idea, guys? What is system software? What is application software? That's very basics. Anyone idea about it? System software and application software. Anyone? Of course, I'll explain very clearly. I'm here to explain everything. I will take care of everything. Tell me, guys, your idea. What is system software? What is application software? Anyone? Yes, you can ping in chat box or else you can speak. Yes, yes, you can. I'm friendly nature. You can speak. Don't feel like a professor or trainer, something like that. Just we are friends. I don't mind even you speaking wrong. No worry. Even wrong answers saying here, no problem, no issue. You can speak. Yes, you can speak just like
Sir,
a
system software is basically a software that manages the computer's hardwares, and it also gives the environment or a platform for application software.
good. Next. Yes, you can speak freely. No
Yeah, I
worry.
think sir, system software is which is softwares which are inbuilt coming in, means like Windows, we have IIS server, then we have control panel. These are inbuilt, but application which we are installing from our side. So these
Yeah.
are considered as a
Fine.
application software.
Good answers. Next, any others? Of course, I am here to explain. Okay. Yes, you can speak. No worry here. Yes, you guys. I don't mind anything here. Even you speaking wrong here, I don't mind. Okay. Yes. Okay. Yeah. Omkar related to voice. Okay. Good. Yeah. Let us see. System software. Yes. What is system software? See, system software. System software. It always interacts with. Yes, interacts with hardware components. Interacts with hardware components. Interacting with hardware components. System software. System software. It interacts. It interacts with hardware components. Okay. System software. It interacts with hardware components. For this best example, OS. OS is a system software, operating system. Operating system. Operating system is a system software. Okay, it's a OS. Okay. So system software, it interacts with hardware components. Yes, example, operating system. Operating system is Yes, system software. Next, application software. Application software. So what is application software? This is for the purpose of application development. Application software is for the purpose of application, for the purpose of application development, for the purpose of application development. Application software for the purpose of application development. Okay, application software, best example, Java. Java is application software. Java is application software. C and C++ is application software. Okay, right. Next, databases are application software. Okay, right. Yes. Yes, maybe Python. Python is application software. Suppose HTML is also application software like this. There are many application softwares. Okay. Yes. So application softwares for the purpose of application development. Applications, apps. See, in our day-to-day life, we are using many applications, right? In our day-to-day life, we are using many applications. See, in your mobile, there are many applications. Many applications, right? So, which is mostly used application in your mobile? Which is mostly used application in your mobile? Tell me, guys.
Social media.
Yes, social media. Okay, next.
Outlook, Teams.
Mostly used application. Which one using in your mobile mostly?
YouTube,
YouTube,
Instagram.
Instagram. No, one thing is
WhatsApp.
missing. WhatsApp. WhatsApp is the mostly used application, right? No doubt. Everyone will be using WhatsApp only, right? WhatsApp is the most used application. WhatsApp is application. WhatsApp is application. Okay. Yes, like Facebook is an application. Yes, Insta is an application. Yes, GPay, Google Pay is an application. Okay, right? Phone Pay is an application. These are all applications, right? Phone Pay. Next, online shopping, online trading applications, online trading, trading rates. With online shopping applications here, online trading applications. Next, banking applications, banking apps, banking system. So banking applications. Okay. Next, Amazon online shopping,
The
Flipkart online shopping.
railway. Sorry.
Like this, there are many applications. These are all the applications, right? To develop this kind of applications, we need some software. Yes, like Zoom, even Zoom also application, right? Zoom, that meeting application. Okay. So these all are applications. To develop these kind of applications, we need some software. To develop this kind of application, not only is like some school management, college management, hospitals management, insurance domain, banking domain, e-commerce, like that, there are many applications, right? How to develop this kind of applications? To develop this kind of applications, we need some software. We need some software. That software is application software. Application software for the purpose of applications development. Yes, best example application software is there are examples of application software. Java is a mostly used application software. Yes, even .NET also application software. .NET, Hadoop. Next. Yes, there are something like some languages. There are many languages. It's application software. There are many tools. See, languages. Language like Java, C, C++, Python, HTML, Perl scripting, Java scripting, like this. There are many languages. Next, tools like data analytics tools. Yes, infrastructure related tools like AWS, DevOps. Next, big data tools here, Hadoop related tools. Okay, right? Next, packages. There are many things, right? In software, there are many things here. All these are application softwares. Packages like MS Office, Oracle ERP, Tally. All these are application softwares. See, yes, software which is interacting with hardware is a system software. See, only OS can interact with hardware. Only OS can interact with the hardware. So OS is a system software. Except OS, remaining are our application softwares. Yes, we are using more than 100 technologies. Hundreds of technologies we are using in the software industry. Hundreds of technologies, right? So which is exactly application software? See, except OS. See, only OS can interact with the hardware components. Only OS can interact with the hardware components. So OS is system software, except operating system. Remaining all are application software. Remaining all are application softwares. Application softwares. Remaining all are application software, right? Application software. So what are the technology using all our application software except OS? Okay, like AWS tools, DevOps tools. Okay, C, C++, Java, databases. Next, Hadoop, big data tools. Next, reporting tools, testing tools. Okay, all are application softwares except OS. Yes, you guys tell me some examples of operating systems. Operating systems example. Now, which operating system using in your
Windows.
Windows,
Windows? Windows is a OS, right? Yes, Windows. Next,
Linux,
yeah,
Ubuntu.
Linux is also OS. Yeah, Ubuntu is one of the flavors of Linux OS.
Kali.
Yeah, Kali also one of the flavors. Yes, in Linux we have different flavors. Linux
Mac
flavors.
OS.
Yes, Ubuntu is one of the Ubuntu, Kali, Red Hat. Okay, like that we have CentOS. Those all are Linux flavors. Next, Mac OS. Next, Unix, very old operating system Unix. Next, Solaris, right? Next, in your mobiles, what are operating systems in your mobiles?
Android.
Android.
Android,
iOS,
Android, iOS, right? iOS. Okay. So these all are operating systems, right? Except these things. Remaining all the technologies are application software. Except these things, except operating, just simple. It's very simple. Yes, except these operating systems, remaining all are application softwares only. Remaining all are application softwares. Okay, fine. Now let us see about OS. What is OS? Topic about OS. See, today topic. It's there in document here. This document for you only. I'll share with you. You guys, running notes is not necessary. Running notes is not necessary. Just you follow this document every day. So every day, yes, this is around 860-page document. I'll share with you. Okay, same as this. My order of explanation in the notepads or anywhere, maybe sometimes using Word and Notepad. This order of explanation and document are the same. This document completely my experience prepared. My experience. See, today topic, introduction to software. It's a collection of programs such as C, C++, Java, and all that, right? Software basically two categories. System software, next application software. System software, application software. See this. System software, it interacts with hardware components. Best example was application software for the purpose of application development. This kind of applications. Example of application softwares. C, C++, Java, .NET, and this. See, except operating systems, remaining all are application softwares. Except operating systems, remaining all are application softwares. Now tell me what is Java? System software or application software? What is Java?
Application
System software or application software? Java is an application software for the purpose of application development. Using Java, we are developing applications. Using Java, we are developing applications. So Java is application software, right? Yeah. So our topic is about application software. So before going to application software, let us see something about OS. Okay. See, next topic, application software. Before application software, let us see something about OS. Yes, about operating system. So now topic is about OS. Let us see about OS. OS, operating system. Yes, some question for OS, some question, very simple question. Very simple question. Can we run? Yes, 1 second. See, can we run? Yes, 1 second. Yes. So about operating system. Yes. So question for you guys, some question, simple, very simple question. Can we run any program without voice? Yes, anyone can answer this. Question is, can we run any program without voice?
No.
Yes, sir.
No. Answer is no. Because if no is no computer. See here OS, a Windows OS, it's a Windows OS running, right? Windows OS running. On top of Windows OS, all are running, right? Like Zoom application running on top of it. Zoom running. Okay. Yes, next. Suppose this Eclipse. Eclipse running here. Okay. Yes, Notepad running. There's Excel running. Like there are many things running on the OS, top of OS, right? That OS is responsible to run all the programs. So without OS, we cannot run any program. No, answer is no. Okay. See, in your system, there is a BIOS. What is BIOS? BIOS stands for what? Anyone idea? What is BIOS? BIOS stands for BIOS abbreviation.
BIOS is a chip, I think. It is a chip.
Basic input output.
Yeah, BIOS is a chip. Yeah, someone saying.
Basic input output system.
Yeah, good. Good. Yes, basic input and output system. BIOS is a, yes. So BIOS, see, except BIOS. See, except BIOS. Yes, to run all programs OS requires. All programs OS requires. OS requires. See, BIOS is not a software program. BIOS is a chip. That chip contains one hardware program. So BIOS. So BIOS stands for basic. BIOS stands for basic. Yes, input, basic input and output system. Basic input and output system. BIOS stands for basic input output system. So BIOS stands for basic input and output system. Basic input and output system. So what is exactly BIOS? See, BIOS is a hardware. So BIOS is a, yes, BIOS is a hardware program. Hardware program. Yes, it's a chip level program. It's a, yes, in your system there is a BIOS chip. That BIOS chip contains some program. So it's a, yes, it's a chip level. It's a chip level program. It's a chip level program. Chip level program, right? Let me show that BIOS. Yes, in your computer, there is a BIOS. BIOS image. See that? So this is BIOS. See motherboard, right? In motherboard, there is a BIOS. BIOS is one chip. This BIOS chip contains some program, BIOS program. See what's the task of this BIOS? What it will do?
It helps
BIOS,
system
what
to
it will
boot.
do? Yeah, 100%. Correct. So BIOS is responsible to boot your OS. So this BIOS is responsible to boot your operating system. So you can BIOS. So BIOS is, yes, BIOS is responsible. BIOS is responsible to boot operating system. To boot operating system. To boot operating system. Right? Booting process. What is booting? What is booting? What does mean? What is booting?
Starting the operating system.
Yes, booting. It's very simple. Yeah, you can mute from your side. That is giving echo. Geeta Pandit. Just you mute from your side. Mute your computer. Yes, in your computer, there is a mute option, right? Yes. Yes. No BIOS. So you can BIOS is responsible to boot. Yes. So BIOS is, yes, here there is a mute option. Yes, here there is a mute option. Just mute here like this. Just mute. So you can't, no, cannot getting that echo. Just mute this like this. Okay. So BIOS is responsible to boot operation. What is booting here? Booting. See, booting is a process. Booting is a process of loading ways from hard disk to RAM memory, hard disk to RAM, hard disk to RAM. Okay, so booting is a process of loading ways from hard disk to RAM, hard disk to RAM, right? See, hard disk, C drive, D drive is a hard disk, right? In C drive, Windows OS, right? It's OS. So the complete Windows OS in the C drive. Hard disk is for the storage. Inside of hard disk is a Windows OS, right? Windows OS, right? So once you power on system, first of all, power goes to BIOS chip. So initially, power goes to BIOS chip. In BIOS chip, there is a program. That program just loading ways from hard disk, from C drive, Windows OS, right? Loading these ways from hard disk to RAM memory. Once loaded, your system is ready, right? Now this OS is running inside the RAM memory. That OS storage in the disk, C drive. In C drive, Windows OS stored. Once you power on system here, now BIOS program loading this OS into your RAM memory. Loading into RAM memory, that is booting process. It's a booting process. Now, see this. This Windows OS running in the RAM memory. So this OS running in the RAM memory, right? OS running in the RAM memory. Now system is ready. Okay, so we have got BIOS. Okay, right? Yes. So BIOS is a first program in your system. Once you power on system here, first of all BIOS starts, that will load the OS. So first BIOS and next OS. In your system, first BIOS and next OS. Okay, right? Yes, now OS is ready. Now what is operating system? Let us say about OS. Now once booting is done, OS is ready, system is ready. Now, what is an operating system? Let us see. What is an operating system? It's about OS. Topic is about OS. What is an operating system? See, in our computer, there are different layers. Different layers in your computer. There are different layers. Yes, here there is a hardware layer. Hardware layer. On top of hardware, OS is running. Operating system running. On top of operating system, yes, programs like C and C++. Okay, maybe Java program running, maybe Python, the scripting running. Yes, maybe databases running, databases. All are running on top of OS. Even MS Office also OS required. To run MS Office also OS required. Okay, see, all these are application softwares. All these are application software. Right? Yes, to run all these programs, OS required on top of OS. On top of OS, all the programs running. Okay, so there is a hardware. On top of hardware, there is a OS. So OS interact with hardware components. So OS is on the top of hardware. So OS can interact with hardware. On top of OS, there is application software. See, this application software cannot interact with the hardware. No, cannot. This application software is running on top of OS. See, everything running on top of OS only. Maybe C programming or C++ or Java, Python, databases or tools or packages. So what are the technology we are using? What are the tools using? What are the applications? All are running on top of OS. These all are running on top of OS, right? So OS is system software, right? It is system software. It's a system software. OS is a system software. Okay. So this whole thing is your computer, right? This whole thing is a computer. Yes, computer aware. See, at the beginning we have discussed it. Computer aware. So there is a hardware and software. In computer aware, there is a hardware and software, right? Hardware and software. See, hardware, on top of it, software. This whole thing is computer. Right? See, in software, there are two things. Application system software, application software. Software, system software, application software. System software, application software. See that. Software, system software, application software, right? This whole thing is computer. That's computerware. In computerware, there is a hardware and then software. In software, there are two things, system software and application software. So system software interacting with hardware components, that's it here. So OS is system software. Okay, fine. Okay. See, on top of OS, all are running, right? All the programs running. All are running. Me even Zoom application also running on top of OS. Zoom application or Eclipse, MS Word documents or Excel, okay, Notepad, all are running on top of OS. See here, Word document running on top of OS, Notepad running on top of OS, Excel, these are running on top of OS, browser running on top of OS. Okay, right? Yes, next. See, so this one, right? Zoom also running on top of OS. All are running on top of OS, right? On top of OS only. So that means OS just is giving platform. So OS it's giving platform. On top of it, all are running. That means it's working like a platform, acting like a platform. So what is OS means? Simply answer is a platform. So OS, yes, it is a platform. It's a platform. OS is a platform. OS is a platform. OS is a platform. It's a platform where we can run, all the application software, where we can run all application softwares, all application software. So OS acting like a platform. So what is OS means? It's a platform. OS is a platform. OS is a platform where we can run all the application software. It's a platform. It's a platform where we can run all the application software. Clear? It's a platform. So OS is a platform here. OS is a platform. What is OS means? Simply it's a platform. It's a platform. See, yesterday we have discussed something here. Yes, Java is independent of platform. It's platform, right? That platform is OS here. Here it's a OS. Platform means here it's a OS here. Okay. 1 second. Yes. So OS, it's a platform where we can run all the application software. See, OS not only platform here, OS, not only platform. Suppose these programs generating some output, C plus Java, these programs generating some output. Output of all these programs, first of all, transfer to OS. Output of that programs, first of all, transfer to OS and they deliver to output device. Okay. So you can all programs, output first of all, transfer to OS and then deliver to output device. Suppose input data, keyboard, from the keyboard. So keyboard, that hardware component keyboard data also simply goes to OS first of all. Then transfer to our programs. Suppose C program reading data from the keyboard. So first the keyboard data goes to OS to our C program or Java program, something like this. So between this application software and hardware, there is a OS, right? So this is something like a mediator. That is working like a mediator between application software and hardware components. So mediator means we can say exactly interface. Simply we can say it's interface. Yes, it is an interface. Yes, it is an interface. It is an interface. It's an interface. It's an interface. It's an interface between application software layers. So it's an interface between this layer, application software and hardware layer. So between these two layers, OS will come. So OS is between these two layers, application software layer and hardware components layer. Hardware components, right? Hardware components. Yes, it's an interface. It's an interface. Okay, hardware components. Right? Hardware components. Okay. So your OS is an interface. It's an interface between application software and hardware components. Right? Next, one more point about OS. Some important points. Java perspective. Yes, that related to Java. Java prospect, some important points. In OS, there is a library. In OS, there is a library. That library contains, yes, inputs and output functions. Okay. So in every ways has its own library. Windows, its own library. Linux, its own library. Unix, its own library. Like this, every ways has its own library. See, that library contains what? Input output functions. Input and output functions to perform I/O operations between application software and hardware components. So instead of OS, this is a library. Library. Okay, that library will perform communication between application software and hardware components. Okay, so see, every OS has, yes, its own library. Every OS has its own library. Yes, every OS has its own library to communicate. Yes, to communicate. Yes, between application software and hardware components. So inside of OS, there is a library for communication purpose. Okay, right? This library for communication purpose. Okay, fine. Next, one more important point in Java perspective, some important points. Suppose C program running, Java program running, Python, all programs, right? Whatever, before going to start running this program, before going to start executing or running this program, first of all, these programs linking with OS library. After linking, then communicates with the hardware. So first of all the programs, every program has to link with OS library. After linking, then program execution starts, then output delivered to output device. Every program has to link. Okay, so every program has to remember this fourth point, important one. Every program has to link with OS library before going to run it. Before going to run. So every program has to link. Every program has to link with OS library before going to run it, right? Before going to run it. Here. That linking may be statically linking or dynamic linking. That linking may be statically or dynamically. Static linking, dynamic linking. The topic we'll discuss in Java. In Java, we have the topic like Java features, independent of platform. Java is an independent of platform, right? That time we'll discuss. That linking topic. Statically, dynamically. That point I'll explain with Java. Okay. Just remember this fourth point. Every program has to link with OS library. That link may be statically or dynamically. Okay, fine. So this is about OS. So what is an operating system? It's a platform. It's a platform. Next is interface. That's it here. Okay. Same thing. Explain the document or see this document of OS. See about BIOS, that explanation. About OS explanation. See that's hardware, operating system software. Yes. So whatever topics we are discussing, all are prepared in the document. Yes, all prepared in document. Just to be cool, try to listen this class very clearly and follow this document. Okay, you guys don't try to write any running notes. Okay, try to concentrate on the class. You try to concentrate on the class, concentrate it here. Don't write any running notes, not necessary. Everything is a document, same order. My class order and this document order is same, no change. Okay, even single line is not missing. Okay, fine. Now here Java. Java is application software, right? Java is application software. Now let us move to application software. Now topic is about application software. See, in application software, there are some front-end softwares and some back-end softwares. In application software, some front-end softwares are available, some back-end softwares are available. What is Java? Is it front-end or back-end? Java front-end or back-end? Let us see. See, this is application, web application. So this is web application architecture. Yes, it's a web application, right? Web application. Web application means World Wide Web, means internet. World Wide Web is internet. See, any application running on the internet is a web application. Any application running on the internet is a web application. See, Zoom app is a web application, right? Zoom application, Facebook application, WhatsApp, like this, all these applications are web applications. Web applications running on the internet. In web applications, there are two parts. There is a front end and back end. There are two parts here. So this is front end part. This box is a front end, right? This box is front end. Next, this box is back end, right? There are two parts. Okay. So what is front end here? Front end is a browser environment. Yes, what we can see in the browser, that is front end. What we can see in the browser is a front end. For example, here, yes, I think today you have registered, right? Meeting this, see this form. That registration form, right? This is front end. Yes, registration for first name, last name, email address, phone number, and all that, right? So this is the registration form, right? Is registration form. This is front end. Registration form, it's a front end, right? It's a front end. It's a front end, right? Suppose inbox. See, so this is my email information. So this is what, it's a front end. The browser environment is a front end. It's a front, so the front end, right? Browser environment is a front end. This is front end. Okay, browser. What we can see in the browser is a front end. What we can see in the browser is a front end. That is front end. Okay, right? Next, back end. In back end, this is application and database. Application database, right? Application and database. Now, suppose in front end, for example, in front end, get the registration form. So this is the registration form, right? This form data. So this form in the browser. So it's a browser environment. That form data. Simply that form data. Yes, in browser form, fill the form, submit. Once submitted, the data simply posting to application. Posting to application. From the application data, simply inserting to database. Inserting database, right? Okay. That application may be Java application or .NET application or Python application. There are different applications using at the backend. So backend applications. Now this is database, backend database. Okay, right? See. So front end. See, person, yes, the person who is working on the front end, like HTML developer, developing HTML forms, HTML reports, CSS, JavaScript, who are working on the front end UI, user interface, right? That develops a front end developer or UI developer or front end developer, anyone same. UI, user interface, UI developer, maybe using AngularJS, React.js, UI developers, right? Front end developer, UI developer, same. Next in backend, yes, this application and database, right? Yes, this application developer and database developer. Application developer and database developer. Totally, how many roles here? In this application development, how many roles here? UI developer role means front-end developer role. Next what? Application developer role. And next what here? Database developer. Totally, how many roles here? 3 roles. Totally 3 roles, right? 3 roles. Okay. So previously, very old days, yes, companies used to take, yes, 3 persons for 3 roles, 3 resources for 3 roles, right? But nowadays, who is having all skills? They are getting jobs. So person who is performing all 3 roles is a full stack developer. Person who is performing all 3 roles, like front-end developer role, in back-end application developer and database, who are working on 3 roles is a full stack developer. Suppose back-end application is Java, then Java full stack developer. So .NET full stack developer, Python full stack developer, Node.js full stack developer, like this. So all full stack developers common, front end and database is common. Every full stack developer must have front-end development knowledge and database knowledge here. That SQL knowledge, SQL, PL, SQL, Oracle database. Every developer, every full stack developer must have front-end and database, right? Yes, so these two common. So front-end and database is common, both are common here, but is different. Okay, if it is Java full stack developer, here Java. Suppose here Java full stack developer. So Java full stack developer must have the front-end knowledge, Java knowledge, and database. .NET full stack developer, front-end, .NET knowledge, and database. Python full stack developer, front-end, database, and Python knowledge, right? That's it here. That is full stack development. In full stack development, there are 3 roles: front-end developer role, application developer role, and database developer role. See, any guys wanted to take Java full stack development course, yes, you must have all this knowledge here: front-end development, Java, and database. So first you start with Java, right? Java. So first initially core Java started. After finishing core Java, you can focus on remaining others. Core Java, advanced Java, frameworks, next UI and database. Later you can focus. First of all, try to finish core Java. If you good at core Java, then you can continue for Java full stack. Then easy to understand it. Okay. Now Java comes here, right? So where exactly Java comes here? Now Java is a application software. Okay, fine. Yes, is it front end or back end here? Now Java comes here, right? Here Java comes. So this is Java. So here Java comes. Right? So where that Java is here? Backend. Backend application software. Java is application software, is a backend. So Java is a backend software. Server side programming. See here, front end called as a client, backend called as server. Client and server. It's a client and server. So backend, Java is a backend software. Java is a backend. Okay. See, application software is a front end and backend. So Java comes here, backend. Java is a backend software. That is clear. Java is a backend software. Okay, fine. Next, one more thing here. The front ends, backends here, there are 2 things: language and package. Language and packages. Package ready-made and ready to use. Like MS Office is a package. Yes, ERPs like Oracle ERP, SAP ERP, Tally, and all these packages. In packages, don't have any coding, no coding in the packages. Next, languages. If it is language, it's a coding completely. It's a programming. What is Java? Language or package? What is Java? Is language, right? Java is language. Now our topic is about languages. Let us say about languages. So what is language? What is a language? See, we are speaking many languages, right? Depends on person facing here. We are speaking different languages, right? Like English, Hindi, Telugu, Tamil, Marathi, Gujarati, like that, right? Why? Communication purpose. Communication, right? So language is a media of communication. It's a media of communication, right? Okay, fine. Now come to software. Software languages. Yes, when come to software, see, computer understanding some language, we are understanding some different language, right? Our language different, computer understandable language different. Okay. So in software languages, there are 2 things. First one, computer, yes, understandable, computer understandable language. First one, computer understandable language, right? Second one, yes, user understandable, our language, user understandable. So first one, computer understandable language. Second one, user understandable language. Yes, what is computer understandable language? Let us see about computer understandable language. See, computer understandable language. It depends on generation of computers. Yes, it depends. See, it depends. It depends on generation of computers. Generation of computers. Generation of computers, right? Yes, now one more question for you guys. Okay, one more question. So I'm asking all these questions. Okay, yeah, one more question. How many generation of computers? How many generation of computers? Anyone idea? How many generation of computers? Search in Google. Yes, you are online student, right? So you can search in, yes, in your mobile, open that search in Google. You can see all that. Yes, in your laptop, open browser, search in Google. How many generation of computers? How many generations are showing here? How many generations? No one searching. How many generations of computers here? Yes, still anyone have the idea? Just to tell me.
Sir,
How
5
many generations?
generations.
5 generations. There are 5 generations. Totally 5 generations. 5 generations, right? 5 generations. What is first gen computer? What is
Sir,
first?
first generation computer works on the assembly language.
No, vacuum tubes.
Oh.
Vacuum tubes. So assembly language, those things, assembly language, machine language, these are later. So initially vacuum tubes based. So vacuum tubes based, initially it's electronic subject. Vacuum tubes based here. Second generation computer. Second generation computer. It's a transistor based, transistors. Transistors, right? Transistors. Transistors based. Second generation. So what is third generation computer? Third generation is a IC based. IC means integrated circuits. Integrated circuits. Next fifth gen, fourth gen. So what is fourth generation computer? Fourth generation is a processor based. Means it's now present generation. This is processor based. Processor based. Now this is present generation. Presently we are using processor based computer. Present gen this is. Next fifth gen is a feature generation. Yes, fifth gen. Feature generation. Yes, what is feature generation computer? Anyone? What is feature generation computer? What is feature generation? No idea? Feature generation A based computer. A based. Yeah, I'll explain something about A also. We'll discuss something about A also. Let us see about processor. Presently, we are using, yes, these are old, very old one, nowhere using. Now, presently, processor based. So, what is processor based understandable language? Processor based understandable language. Understandable language is what? Binary code. Yes, it's a binary code, right? Binary code is something like a zeros ones format. Yes, binary code, like a zeros ones format. It's a binary code, right? Okay, processor based binary codes. Next, feature A based. So, what is A based computer understandable language? Yes, processor based computer understandable language binary code. So, what is A based computer understandable language? Anyone? What is A based computer understandable language? Anyone? Have you heard about A? What is A? I'll explain now. Don't worry. See, A based computer understandable language is English. Yes, that can understand our English. Yes. Let us have some discussion on AI. Very interesting point, very interesting topic, AI. So what is exactly AI? See, AI is a technology. Just is a technology to make machines working like a human. That human being, right? Working like a human. So AI is a technology Just it's a technology. AI is a technology to make machines working like a human. Yes. Let us see some example of AI machines. Suppose AI machine. Suppose in your home they say AI machine. What it will do? Yes, that AI machine, yes, it can listen for your instructions. So whatever you says, it will listen for your instructions. Suppose you saying that, yes, open door, close door. Okay, next maybe washing, yes, washing something here. Maybe washing machine timer off on. Okay, fan switch off, switch on. Maybe floor cleaning and all that, like a helper. AI machine. So whatever you says, it will listen for our instruction. Yes, it's a yes, it can understand English. It works like a human. It can understand our English here. Suppose if you saying about some stories, yes, AI machine will listen your stories. Yes, it will listen your stories here. It will remember. Suppose in future, anytime if you're asking some question from the story, respond. Suppose you explain about your ancestors, your forefather, parents, ancestors. AI machine will listen. Anytime if you're asking that question, it respond. Okay. See, AI machine, yes, like a human. Means AI machine, it will take text data and voice data. Yes, like a human, it will take text data and voice data. 1 second. See, this is text data, right? See, as a human being, we are reading this text data, right? So we are reading text data. Of reading text data, we'll remember. So input is what? Text data. Not only text data. Yes, even we can listen. Yeah, we can listen videos also, right? Voice data. Yes. Recordings, okay. So let us see some recordings. Sorry. Recordings, right? Yes. Yes, these are voice data. Yes, as a human, we can listen for this voice data and we can read text data, right? AI machine also same. Same like a human being here. That AI machine will take text data as input and voice data as input. Taking input, it will remember. Whenever you asking question, it will respond. Suppose whenever you're asking any question, what happens here? First of all, your question goes to AI machine. AI machine taking that question and that question sending to backend programming language. What is backend programming language? Java, Python, R language. Okay. AI machine, that machine will take your request, your question. That question simply pass in the backend program. That backend program is Java program or Python scripting or R language. These programs will go to data. What are data? Feed it, right? Like voice data, text data. It go the data and filtering the data. Okay, the Java program, yes, maybe Python scripting, maybe R language, that will filter all the data and giving answer finally, right? So behind of AI machine, the Java program, yes, maybe Python scripting, R language working. Yes, taking data and giving response, right? That is exactly AI machine. Okay, so AI machine, yes, it can understand your English. Yes, it can listen for our instructions. Okay, right? That is one example of AI machine here. Next, suppose one more example, AI-based car. AI-based car, right? AI-based car. Best example, Tesla. And yes, they say Tesla car. Tesla. AI-based, yes, that Elon Musk. Elon Musk has developed some Tesla car, right? Tesla car is a AI-based car. It's a driverless car. Driverless. Driverless car. Driverless car, right? Yes, that car. Yes, as per your instructions. Suppose that car integrated with your mobile. So first of all, that car should be integrating with your mobile. So installing one application on your mobile. Yes, if you're giving instructions through the mobile, that car will go anywhere here. As per your instructions, yes, you have to define the route too. After defining route here, yes, as per instructions in your mobile, Tesla, that car go to required location and picking maybe persons picking, maybe material picking and dropping somewhere. So without any driver, Tesla car will do it. Suppose if you want to park it, yes, using mobile you can park. Parking also using mobile you can operate it. Taking out of the parking, yes, using mobile, right? Okay, so Tesla car like this, driverless, that is AI mission, right? Suppose for example, health tracking, AI tools. With AI tools tracking your health, right? You can track your health. Okay, yes, your body, what is your body response? What is your body behavior? That AI-based mission, yes, will track your body response and your body behavior and recording and keeping it in memory. Suppose last 1 week, what is your body behavior? Okay, and all that it will read it, keeping it in memory. Suppose when you're asking for predictions, next week, yes, what will happen to your body? Yes, that AI machine will tell. So what is happening in your body? AI-based machine will tell it. So that means it's like a doctor. That AI machine working like a doctor. Okay. Yes, if it is car, that machine is working like a driver. That AI machine is like a driver, like a doctor, like an engineer. Suppose, for example, civil constructions. So require some architecture. Just give the, yes, you request that give the architecture simply. So like a architecture. Okay, so wherever human intervention is there, AI is working. Without human intervention, AI working, AI machine working. Okay, like a doctor, like a driver, yes, like a civil engineer, like a mechanical engineer, like a worker, yes, like a software engineer, yes, in place of human being, all AI machines working. That is AI exactly. That is AI based world. I think understand, right? Yes. So whatever human we are doing, all of this is very AI. AI machines will do it here. Maybe manufacturing industry. Okay. Maybe construction industry. Maybe software industry. Okay. Maybe yes, driving cars and all this AI machines will do it here. That is AI based world. Okay. AI based world, right? Yes. So once AI based world by 2035, expecting AI based world. AI based world. Okay. By 2035, expecting AI-based world. See, you guys, some guys may be thinking, once AI comes, loss of jobs. No, no chance. I will tell you reason. I will tell you that reason just a minute. See, someone says that once AI-based world comes, loss of jobs, right? But no chance. Reason I will tell you. What is now world population? 800 crores, right? AI-based world 2035. By 2035, yes, world population will be 1,000 crores, right? See, to meet the requirements of this 800 crores of people, that human efforts not enough. For that, we are using some automated machines, right? Yes, with the help of automated machines, we are serving that 800 crores of people. Okay, still work delay. Even automated machines are there, even this much of technology is there, very advanced technology using here. Even that, still there's a delay in the work. There's a delay in the work, right? Okay, yes. So here, to avoid delay, we are using technologies. We are using machines and software technologies. And we are using social media. There are many things we are using, right? Even many things we are using that works, yes, are become delay now. Delaying simply. Suppose population reached 1,000 crores. Yes, to meet the requirements of 1,000 crores, that human efforts not enough. Something new technology required to meet the requirements of 1,000 crores of people. That technology AI. Yes, if AI comes, then these 1,000 crores of people can survive easily here. With human efforts, these 1,000 crores of people cannot survive. Highly impossible. Okay, to meet the requirements of that much of population, definitely we need advanced technology than the present technology. That advanced technology AI, even AI-based world comes, no loss of jobs. Don't think loss of jobs. That is analysis simply. Okay, no one will tell you about this analysis. Yes, even very experienced software professionals also says that if AI comes, loss of jobs. No, never. Okay. Yes, even highly professionals also says that loss of never happens because the population is growing, right? As long as population is growing, yes, that requirements are going. Requirements are growing, right? To meet that much of requirements, human efforts not enough. For that case, we need something advanced technology than present technology. That advanced technology AA. So AA and combination of human efforts, then surviving easily here. That is AA. I think understand that. That is simply analysis about AA. Okay, fine. Now, so here presently we are using processor-based computers. After 10 years, AI. Still 10 years time is there for AI. Okay. Right. Now here, so processor-based computer. Yes, binary code. That binary code called as low-level language. It's a low-level language. Okay. So it's a software language, computer understandable language is a low-level language. So low-level language, low-level language, low-level language. So low-level language. Low-level language, next user understandable called as high-level language. Low-level and high-level language. Low-level and high-level language. Low-level and high-level language. Okay, right? Yes, low-level language. It's a system understandable language, binary code. Low-level language. Yes, it's a system understandable language. Yes, it is a system understandable language. It's a system understandable language, right? Yes, here system is what? System understandable. System means your computer. Here system means processor. It's a processor. Yes, processor, right? So what is processors like 8085 and 86? Yes, 8086. So before 90s, 8085. From 90s, we are using 8086. Now we are using 8086 computers. Okay. Yes. Its language is binary code. Okay. Processor understandable language in the form of binary code. It's a binary code. Binary code. So binary code something like zeros ones format, right? Yes. How this binary code generating? The topic I'll explain Java. In Java, how that binary code generating, how that every instruction converting to binary format and giving to processor, right? How that converting to binary codes. The topic I'll explain practically in Java. Practically I'll explain. Yeah, this is called as machine language. This is called as machine language. Yes, it's a low-level language, machine language. Next, high-level language. High-level language. Yes, it's a user understandable language. High level. Yes, it is a user understandable language. It is a user understandable, user understandable language. It's a user understandable language. Yes, it is English, right? Simply, it is English. Yes, it's English, right? Yes, example for the high level language. Java is a high level language. Java, yes, C and C++. So these are all the English programs, right? It's English only here. Java, C, C++, Python. These are high level languages. Let me show the Java program. Java program. Suppose here is some Java program. Java program. So this is a Java program. See this? So this is Java program looking like English, right? Yeah, this is framework. Spring framework example. This is. Okay, so Java program looking like English, right? It's looking like English. So C programmers looks like English. So these are high level languages. So these are high level languages. Okay. So it's a high level language. 1 second. Yes. So these are high level languages. Next, HTML. These all are high level languages. So yes, one more question for you. One more question. One more question. Which is first generated? First developed high level language. Anyone can you answer this? Which is first developed high level language? Anyone can answer this? There are many high level languages. Which is first generated high level language? Yes, come on.
C language.
Yeah, exactly. C language. C is a high level, first high level language. Before C language, we have the assembly language. Before assembly language, machine language. First machine language, next assembly language, next C language. That machine language, binary code, assembly language, those are low level languages. Machine language, assembly language are low level language. C language comes under high level language. So first developed high level language, C language. Yes, C language. C language. C language is first developed high level language. C language developed by whom? Who is the author of C language?
Dennis Ritchie.
Yeah, good. Dennis Ritchie. Why Dennis Ritchie, right? Dennis Ritchie. Dennis Ritchie. Yes, in the year 1972. Okay, C language released in the year 1972. That C language is also some history. Before C language, there's a B language is there. Before C, there's a B language.
But sir, in Google it is
But-
showing that different
Yeah.
language, Fortran.
No, 1 second. B language. Before C, there's a B language. That B language not released officially. Before B, there's a language, like algorithmic language. Algorithmic language, B language, and C language, alphabetical order. C is a, no doubt, not Fortran. Fortran, yes, 80s period. C language, 1972. Before C language, first of all, assembly language is there. First machine language, next assembly language, next C language, after remaining all. Fortran, COBOL, Pascal, Basic, and all that, right? That is generation. Yes. 1 second. Yes, even one day I will explain that. Generation, yes, development of softwares. Yes, softwares.
He's saying that 1954 it was
Their software history.
developed by
1945. Machine language. Next MS-DOS. C language. Next Unix. C++. Python. Windows. Foxborough. Oracle. That all the software history one day I will explain. See, since 1993, I have the software awareness. 1993, yes, my student career started. Engineering 93 to 97. 93, computer science engineering, JNTU, Hyderabad. So since 1993, I have the software awareness. I know what was happened in the software field since 1993. So before 1993, nothing is there in software field. Before 1993, just only Unix, C, and Python is there. Python is there, but not used. Okay. So almost all softwares I have seen in my career. All softwares I have seen that release on different scenarios, all that I have seen. Okay, one day I'll explain. So this topic is there. One day I'll show it, not here. At the middle of the course, someday we'll discuss. Okay. Okay, fine.
sir, but in this document you have not mentioned anywhere Fortran, and it is showing that Fortran has been developed in 1954 and released commercially in 1957.
Fortran may be developed, but not commercially, is right? That not officially.
No, commercially released in 1957.
No, I think something wrong. That is.
If you check on Google, I search on Google itself. I have not searched anywhere.
Okay,
Just
okay,
now
we'll
I'm seeing.
discuss. We'll discuss later. Leave it.
Yeah.
Okay. Yeah. C
Okay.
language developed by Dennis Ritchie, 1972. Okay. Generally, anyone says that C is a first high level language. Okay, fine. Yes. After C, remaining all. C language, next OOPS and C++, Python, remaining all. Okay, fine. Yes. See, high level language. System cannot understand your high level language program. System cannot understand Java, C, C++. System don't know about it. So these high level language program has to convert into binary codes. Binary codes. So who will convert from high level language to binary code? High level language to binary code. Which one will convert C program to binary code? System understandable language. Java to system understandable language. C++ is system understandable. Python to system understandable. Which one will convert? It's very simple, this answer. Compilers, interpreters.
Yeah.
Compilers.
Compilers.
Yes, compilers and interpreters. Compilers and interpreters. Compilers, interpreters will convert from high level language to binary codes. Yes, what is compiler? What is interpreter? Some differences are there. There are many differences.
So
Compile,
interpreter reads the instruction line by line and execute.
compile is whole program at a time. Okay, fine. But main difference is there. Compile, interpret the difference. Tomorrow I'll explain exactly. Practically I'll show that. Yes. So up to this topic completed. Tomorrow topic about interpreter and compiler. See, main difference between interpreter and compiler. exe file. exe file. Compiler creating one exe file and executes, but interpreter don't have exe file concept. The topic I'll explain about exe file. Yes, how the compiler generating one exe file, how it's executing, but interpreter never generating exe file, directly code executes. Interpreter is directly code executes, but compiler exe generates, then exe file executes. That's actual difference. The differences I'll show practically. The total 9 differences are there. These differences in tomorrow class I'll explain. So tomorrow topic is about, yes, interpreter and compiler. Next about Java. Tomorrow introducing Java. Java, is it compiler based or interpreter based? Tomorrow we'll discuss. So C programming is a compiler based. Python is the interpreter based. C++ compiler. HTML interpreter. JavaScript interpreter. Okay, what is Java? Interpreter or compiler? The topic tomorrow I'll explain. Okay. The topic Java, is it interpreter based or compiler? Tomorrow I'll explain. Just wait for, yes, one more day. So tomorrow we'll discuss clearly. Yeah, that's all for now. Any doubts? Yes, guys, any doubts?
No, sir.
No doubts?
No, sir, no
Yes.
doubt.
Any doubts? No doubts, right? No doubts, right? Yeah. So for your batch, WhatsApp group create already here. Okay, WhatsApp group created and communication is going. This is my WhatsApp number. Still, anyone don't have this number, take it. 8179-189-123. This is my WhatsApp number. Take it.